Next up, I'd like to introduce Dr. Chaitanya Mahajan from New Mexico State University, who's going to tell us about magnetic field patterning of nickel nanostructures using precursor rings. Here you go. Thank you.
Thank you, everyone. So my name is Chaitanya Mahajan. I'm an assistant professor in the Department of Industrial Engineering at New Mexico State University. So today I'm going to talk about this magnetic field patterning of nickel nanostructures using nickel precursor ring. There were many talks about the precursor inks yesterday as well as today. There are many companies who are working on those precursor rings. So I'll talk about that. The reason for this is like the nickel, there are not many, I mean, I shouldn't say not many, there are a few companies that are working on nickel inks. But nickel has some very good properties because it's a ferromagnetic material, right? So there has some cool properties associated with that. So this work was about using the nickel ink and under the presence of magnetic field, how we can create different structures with that. So biography of, as I said, I'm an assistant professor at NMSU. Before that, I was a lecturer at Kettering. I did my postdoc from Ambient Center, which is in Rochester, New York. I got my PhD and my master's from Rochester Institute of Technology. And I got my bachelor's in production engineering. So these are some of the images that you can see. On the top right, the purple color one, that's the nickel ink. So it doesn't have any nanoparticles in it. Okay. And the structure that you have seen was done with an aerosol printing. So IDS is not here, but it's basically like an aerosol printer, like a fancy perfume, so to speak. But it does, instead of fanning that aerosol, it tends to focus on a specific thing, and then you can create complex shapes with that. And again, we play around with different materials. So this was PEG. When you dissolve in methanol, it will create a solution ink, and once you dispense it, the methanol will evaporate and will give you structures from PEG. Yeah. So nickel has a different, I mean, people have not been using nickel as a conductor because the resistivity is too high. But it has some properties when you want a conductor that is not oxidizing or not getting corroded in a corrosive environment. So that's when nickel comes into picture, because copper tends to oxidize and the conductive property gets affected. Silver is good, but nickel, as I said, like it can be used where there's an oxidation environment, like in corrosive environment and so on. As I said, nickel is a magnetic material. So nickel, ferrous, and cobalt are magnetic elements. So you can create like magnetic sensors like GMR, so giant magnetoresistive sensors and so on. So there are potential applications for that. And the last one is a thermal, where so immersion cooling, we're currently working on that as well, where you can create this passive air cooling systems, or sorry, passive cooling systems, where you can create nickel structures in such a way that it will make sure that the heat is dissipated outside into the non-ionic coolant and so on. So there are like so copper has an electrical application, but because of the nickel, you can have like a magnetic and thermal as well. So I'll just give a background of what this precursor inks is. So the nanoparticle inks that you have seen so many companies, what they do is they have this bulk metal. Okay, so in this case, if I have two elements like element M and element N, you can say that element M can be copper and N can be nickel. So I have this bulk metal, I'll mix them together and I'll create a powder of that. I can grind it down to nanoparticle as well. And this is where the secret recipe lies. You create this nanoparticle ink and you can dispense through any printing method. In this case, the paper was published with using aerosol printing. So you can create these nanostructures with that. And obviously you have to fuse those nanoparticles in order to get the structural integrity. So this process is called as top-down process, where you're melting a metal, creating powders, nanoparticles, dispensing in an ink form, and then, creating a nanoparticle ink, and then dispensing using different AM process. What the precursor inks are, that's what we are studying, is a bottom-up process. So we have this